Ladies and gentlemen, this particular video is aimed at those who are, well, not familiar or basically don't know about programming at all, but want to take their first steps into it. Well, you want to do programming? That's great. But what exactly is in programming? And, well, how do we actually learn it? Today, what I'm going to do is I'm going to give you that 1,000-foot view of what programming is all about. I'll show you some of the key features, the key things you need to know to write programs. And you'll be surprised to find that at the end of this video, right, all the things I've covered describes nearly every single programming language there is out there. No matter what programming language you use, you end up doing the same sets of things. Well, hopefully this is an intriguing thought. More on this after the break. Hello and welcome back to another random Wednesday episode. So the question is, what is programming? Well, first of all, to understand this, we have to understand what a computer actually does. Now, this is a model that I've mentioned many times in many different places, but it bears repeating because don't forget, every single program is exactly the same. They do three things: input, processes, outputs. Here's the idea. On a computer or on a system, essentially, you want your user to give some sort of inputs to the system. The system needs to take the inputs, crunch the numbers or do whatever it needs to do, and after evaluating what it needs to evaluate, produce an answer, produce a result, which is then of course your output, right? It's given back to the user. While this picture seems primitive, it actually describes basically every program ever. Of course, usually things are more complex. For example, say you're surfing the net. You're not the only one supplying inputs, right? Input comes from the internet. Say you're watching a video, your outputs are more complex, right? You get a picture on screen, you hear sound. So when it comes to the whole inputs, processes, outputs model, you are essentially having multiple inputs, right? They're going in to get processed together, and you get multiple outputs, right? Across multiple streams. That is essentially the idea. And when it comes to programming, what you're really doing is you are tweaking up the box in between. Your job is to tell the computer how to actually transform these inputs to produce the output you want. That answers our most fundamental questions of what is programming, but not our secondary question, which is what is in programming. So before we start talking about the features of a programming language, we first need to understand what we are seeing when we look at a page of code. Now, generally, code looks something like this. It's a lot of lines, and essentially, these are simply lines of text. There's nothing special about, what you see, right? At the end of the day, it is just text you type on your keyboard. Of course, there's some programming languages that do not use text, most notably your block-based programming languages, which are drag and drop. But apart from those, it is almost always text. We use this text to represent our intent, and usually each line of code represents an instruction. There are some exceptions to this, but for the most part, you could treat each line of code as just an instruction. And in other words, you can think of each line as really like a little mini program. And that's because each instruction basically behaves like one. It takes in some input, it processes it, and it produces some output. Really, the only difference between an instruction and your entire program is its scale. Usually, instructions perform a single task, as opposed to your program, which of course could be a lot more complex. As you can see, our program here is made up of a lot of lines, and for the most part, these lines are executed from top to bottom. Again, there are some exceptions, there are some times in which we sort of go back upwards, and we'll see that later on. So you can imagine your programming language going to each line, interpreting it, and doing the action that is indicated there. Because we do things this way, what we can do is we can link up multiple instructions. Since each instruction takes in an input and gives out an output, we could chain them together. An instruction doing something would pass its output to another instruction for further processing. This essentially becomes a more complex program. In fact, that's really what a program is. It's just a bunch of instructions that are working together to produce the outputs you want. And that is essentially the general picture of how, well, a piece of code actually works. Keep this in mind as we take a look at all the various features that are available in programming languages. let's start off with tools to manipulate data. Now, here's the deal. When you take in inputs, right, ultimately all of it comes into you as data, right? It could be strings of text, it could be numbers. Throughout your processing, it's all data. You're moving things from place to place, you're changing its values. And again, when you produce output, it's data again. You send your data to your screen interprets that as a picture. You send some data to a speaker, your speaker interprets that as sound. It is all data. So here are some tools you can use to manipulate data. Firstly, variables. Essentially, a variable is a small unit of storage. You can then read from or write to that variable, or maybe even both. For example, a particular action will do different things depending on what value you give it. If you give it a variable that could contain a varying value, then you get different results each time. Again, don't forget, what you're representing is just data, and at the end of the day, all this will go towards shaping your output. Speaking of data, data in programming languages are usually typed. What this means is a variable would hold, a particular type of information, for example, a number or a string of text, and each data type can be manipulated with in certain ways. Certain languages blur this line by allowing you to not explicitly state a type. However, the concept of types are usually still there. While things like numbers and text can be considered simple types, there are also more complex types like collections. You can store a collection in a variable, and when you do things this way, instead of storing just one value, you are storing, a bunch of values. You can then do interesting operations like, for example, visit each item in a collection to do something to it. You can do operations like summing everything in a collection. And yeah, again, this is a different way for you to express and manipulate your data. So at this point, we've looked at data manipulation. Once you know data manipulation, you can take a piece of data and do something to it, right? You can take a collection of data and modify it however you wish. But at present moment, that's it, right? Your program does that one thing, it does the same thing every time, and it quits. That's it. What makes a program really smart? It's its ability to make decisions, also known as flow control. Now, this one is really interesting because essentially there are two things you can do when it comes to flow control. And firstly, it is an if statement. Here's why we need if statements. Now, don't forget your program takes an input, right? And there could be many different inputs. At some point of time, you may want to express the following intention. You may want to say, if something is a certain way, you want to respond by doing a certain thing. But if it's a different way, you want to respond differently to do a different thing. This is where your program starts to, basically have to do decision making. Your program is basically trying to be smart about whatever comes in. This is when you use an if statement. Essentially, if statements are always expressed with a test or a condition. If the condition evaluates the true, the stuff contained within happens. If it does not, that stuff is skipped over, and your code continues on past the if statement. Another tool that is commonly used in flow control is the loop. Essentially, a loop at its simplest acts like an if statement. It checks a condition. If it's true, do it. If it's false, don't. But when it's done doing its thing, it loops back around. It checks the condition again, and if it's true, right, it does the loop body again. Hopefully you can see why this is called a loop. Essentially, this code repeats itself until the condition becomes false. Repetition can be very useful because usually programs are handling large volumes of data, but it's really doing the same thing for each one of these data points. So we write a loop to simplify our lives. Instead of saying how each and every single data point is handled, our loop does it. And this also confers the additional advantage of, having a loop that keeps running no matter how much data you actually have. Whether I have 5 or 500 data points, my loop is just going to see how many there are and run once on each data point. That's something you cannot achieve with a simple copy and paste. So far, we've seen data manipulation and flow control. And in fact, these two alone is enough for you to write essentially a full-blown application. Remember, the model is inputs, processes, outputs. And at this point, you are basically able to express something potentially very complex in the middle box, right? Your processing can be very complex, and at the end of the day, as long as your data goes to the right place, you will get the right output, the output that you want. Of course, there are other things that are available as well, and these are things you want to look at when you are slightly more familiar with the basics that we've just talked about. Firstly are functions. When your program gets bigger, functions are a good way to group a bunch of code together. Remember how we said earlier on that an instruction was basically like a mini program because it takes in some input and produces some output? Also remember how we could actually string together multiple instructions to create a program? Well, that could basically be the end of the story. Our program could essentially just be a bunch of instructions all chained together. However, when we get into the realm of functions, there is one more thing we can do. We can group our instructions together to form a function. This function then also acts like a mini program, but again, the difference between these two lies in their scale. An instruction usually does one small step, whereas a function will be a grouping of instructions, and the idea is it's going to perform one particular task. Your program is of course broader than that because it's not just performing one task, and generally how we would build our program is we string multiple functions together. Since our program will involve, doing multiple tasks, perhaps not always in the same order, we can always write the solutions to each one of these little tasks as functions, and at the end of the day, to build our entire program, we'll string those functions together. This of course gives us our final program, which can be used to solve very complex tasks. So yeah, this is essentially where functions come into the picture. As mentioned, they are completely optional, but they can help you in getting your code organized. When you're building something very large scale, you want to think in terms of functions. Every little capability is a mini program, and to make your big program, it's a lot of little mini programs talking to each other. This allows you to clearly compartmentalize your code, and it makes finding problems or adding new features easier. Another intermediate to advanced feature would be error handling. Of course, from time to time, you expect things to go wrong, sometimes not because of your code. For example, a user could enter a wrong input, and you want to be able to handle it. Quite a few programming languages are capable of creating what are known as exceptions or errors. These are essentially problems that crop up during runtime, and if you were to handle them appropriately, your program can actually continue along. Knowing how to handle errors makes your program more robust. It makes your program fail elegantly and pick up from the failure, right? It won't just crash. Finally, another feature that is definitely great to know are your packages. The idea is, most of the time, you don't have to write an entire program yourself. Code already exists out there that you can easily bring in, and that will make your life better, right? Because you have to do less work, and chances are, whatever it is you bring in has been tried and tested. So to a certain extent, you have a guarantee of correctness. Technically, knowing how to work with packages is completely optional. You don't have to know, but knowing makes your life so much better. Again, if you bring in someone else's code, it acts like a mini program within your program. Again, it is a black box. You don't have to care about what's happening inside with the processing. Just know that when I give it certain input, it gives me back certain output, and you can use it that way. So yeah, essentially, these are all the key things in programming. When it comes to learning how to code, you will definitely want to know at least the basic two: data manipulation and flow control. When you learn programming, these are the tools that you will be picking up, and these are the tools that you have to get used to before you can actually start writing code. From a 1,000-foot view here, hopefully you have a better picture of what a program is actually doing, right? How it's actually able to achieve what we want it to achieve. So hopefully with this picture in mind, right, every single thing you learn as you learn programming can be fit into this picture. If you can do that, you'll have a better idea of how everything hangs together. But well, that's it. That's all there is for this Random Wednesday episode. All the best for your journey in programming. It may be daunting at first depending on what language you've chosen. By the way, if you're interested to see what language to choose, well, check out this video that I've done some time ago. I weigh up some of the more common languages so you can pick one and get started with. But yeah, things are going to be a little bit daunting at first. Don't be too worried, right? As you move along, the more you practice, the better it's going to get. And yeah, hopefully sooner rather than later, all the thought processes fall in place and coding becomes second nature. Anyway, again, that's it for this video. Thank you very much for watching, and until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.